Without further ado, let's derive path line. Okay, so if x and y is equals to 0.2, 0.8 was the initial position of the fluid particle, what will be the new position of the particle at time t equals to 6 seconds? Okay, so let's say if it is x0, okay, so as I said, at time t is equals to 0, it is at this point, right? So because so the keyword itself is that was the initial position of the fluid particle. So when you say that it is initial position of the particle, you're saying that when time is equals to 0. So we're talking about when time is equals to over here. And when 6 seconds, it may be somewhere over here. Okay, I don't know. So we'll check it out. So what will be the new position of the particle at time t equals to 6 seconds? So let's do. So for path line, you remember u is equals to ax, y is equals to minus ay, right? This is the equation that we have been talking all about. Okay, u is equals to dx over dt, v equals to dy over dt. We're talking about this now. So nonetheless, u is equals to ax and y equals to minus ay, which is from this equation, if you remember. Okay, so yeah, ax is the x direction velocity, while minus ay is the y direction velocity. So we have this over here. Because u is the x direction velocity, v is also the y direction velocity. Okay, I think you know what I mean. So thus to now, the equation of x and y, which we can use to plot the path line. So we can now use the this relationship. We know that u is equals to ax, so let's put over here. Okay, which is also this one. Okay, the same thing. Nonetheless, minus ay you just sub as v. You just put it over here. See, this should be v. I don't know why I put it as write wrongly. So I just okay. So you have this relationship, and you rearrange into separable equation, and then you integrate. Okay, you just bring the x down over here, and then you bring the dt up, and then you integrate. Same as the y portion over here. So eventually you'll get ln x equals to at plus c. Okay, because if you were to integrate, okay, so and if you integrate a, okay, you have at, right? Then you integrate 1 over x because you bring the x down. So you have this thing over here and this thing over here. Okay, be careful when you are dealing with these two equations. Ln x, if you are dealing with this, if you are integrating x, okay, plus c. If you are integrating y, you have some other constants. So this constant is different from your c constant. Okay, so be very careful when you do this. So what we're actually doing is actually to find an equation for x and y. As we have said earlier, x and y is equals to 0.2 and 0.8 each, right? So we want to have an equation so that we can actually use this equation and then to find something that we can actually when you have the equation you can actually plot some t value. So because we want to find 0.6, right? We want to find 6 seconds, right? So you just plot it out, So what we are doing is actually to find a relationship and an equation to describe x and y. So since initial position, this means t equals to 0, as I said earlier. So ln 0.2 is equals to 0 because this equation is, if t is equals to 0, this whole thing becomes 0. So we have ln 0.2 is equals to c, and then same thing over here also. Okay, so we have ln at equals to d. You may wonder why you put ln at where you're talking about 0.8 over here, because there's a typo error over here. It should be 80. So yeah. Okay, so therefore at t is equals to 6, we can sub in c and d back into our equation. Okay, so since we know c is equals to this one and d is equals to this one, let's sub back in into, so you just sub this back over here. and then you sub this back over here. Okay, so I've rewritten it in this portion over here, the same thing. And also that we know the A value is actually given that is 0.3, so you just sub it in. And then you do up the math. It is pretty simple one. You just get 1.299 and 13.2236. But if you want to have a general equation, okay, because you're just saying that if its time equals to 6 seconds, so when I sub in 6 seconds, okay, I will have some, because ln x, if you were to multiply with exponential, you get because ln ex is equals to 1, so this is x, and then e to the power of 1.8, okay, plus all these things over here. So nonetheless, this is a, and this is t, and this is plus ln 0.2. That's all. Okay, yeah, and then yeah. So if you want a general equation, okay, what I do is actually to recommend you to do this way. So you have a ln x is equal to 0.3, 6 seconds plus ln 0.2, right? You bring this ln, typically you want to bring every ln in the same term so that you can, if it's divide, you minus or whatsoever. So imagine if I were to put ln x and ln 0.2, okay, if I were to bring this down over here, you have a x divided by 0.2, and then you exponential them, you have x divided by 0.2, okay. So this 0.2 will come up over here, you have over this thing. So what is this? This is actually 0.3, 0.3 times 6. And so 0.3 is the A and 6 is the time. So in general equation can be said that 0.2 EAT is equals to x, and AT minus AT is equals to y. This is the same method from here, so I'm not going to explain this. And then just take a look and pause the video and look around. Okay, so so with this two equation, this is how I got my values of x, my value of y, and these are all my time. Okay, these are all my time. Because I pulled it out too much. So at time 0, we'll start over here and then we'll just run the thing. Then you may ask me what is this actually. This is now some random testing values that I gone wrong. And this top one is some random testing that I've gone wrong also. So don't care about these things. You just care about this one that will be do. So when time is equals to 0, you have 0.2 and 80, right? So this is why this is over here. Okay, because this is over here lah. Okay, if you have some streamline constant that is, let's say there is 1, then you have this portion over here. So with this thing, we know that we have this equation, and also that we know that t is equals to 6, x is equals to 1.2099, and y is equals to 13.2236. So where is it actually? So let's take a look. So if x is equals to 1.2099, it will be somewhere over here. 1.2099 is somewhere over there already. Okay, so hold on a while. Because my increment is in terms of 0.1 second, okay, my increment is in terms of 0.1 second, that's why I only put until 5.5. So 1.2099 should be somewhere over there. So yeah. So this is only the value for x and y, but nonetheless it cannot determine the rest of the flow, the rest of the particle. So it's just saying that x position and y position, that's all. While the relationship between x and y is all determined by what streamline value you are. Okay, so the streamline value is another story. So we have also explained how to derive the streamline, and then yeah. So we have mainly cleared all the path line and the streamline. So in the next video, we'll just answer these two questions. Okay, find the velocity, magnitude, and comment on whether the wave particle is accelerating or decelerating. And then this portion here is a little blurry. I don't understand much about this. Nonetheless, and then we'll talk about this thing. It's just a quick example, and then we'll call it a day. So see you in the next video.